In the first case, you got a fundamental first harmonic. In the second case, you got a second harmonic. In the third case, you got a third harmonic. So you see the pattern. So if you have a question that tells you the fundamental frequency is, say it's 345 hertz, and they ask you the third or the fourth or the fifth or seventh harmonic frequency, whatever it is, you just multiply it by whatever. So if this were the third harmonic, then you would multiply this by 3. And likewise, if you were given the fourth harmonic and you were asked to give the fundamental harmonic, you would divide the fourth harmonic by 4 and you get the fundamental harmonic. So that is the most basic theory application problem. Now that we have this chart, we can apply this into open air columns. Open air columns are the same concept, except they just look a little different in diagram. We know that for something to resonate, there has to be antinodes at each end. So this is the first harmonic of the open air column. It looks like this, but what you can actually realize is it still looks really similar in that you got this, which is just equivalent to this in the first diagram, to this. You got 1/2 here, you got 1/2 here, so what you end up getting is this. And this is the first harmonic, and for open air columns, the fundamental frequency length will be given by this equation. Now we can continue on. The second harmonic of an open air column is going to look like this. So you see there's one hole in here, and you got 2 halves, which is equal to what we got earlier, second harmonic, and the expression is given by length equals wavelength, because we got one whole wavelength here. And then last of all, this time we'll have 2 full ones in here, and then we'll have 2 half ones here. So you can tell this is a third harmonic, 1, 2, 1/2, 1/2, third harmonic of an open air column. Okay, so these are the expressions for the first 3 harmonic of an open air column. You'll see where this comes in handy later, but now I'll explore the closed air column. The closed air column for the first resonant frequency. Now, you see that in open air columns, all these 1, 2, 3 harmonics will resonate because you got antinodes. But in a closed column, not all harmonics will resonate. So let's just understand what's going on here first. Okay, closed column, antinode has to be at the opening, and the most fundamental frequency you can have is with a node at the end. This is the first harmonic given by this equation. The wavelength present here is 1/2 of what should be a whole wavelength. And this is our example of a whole wavelength. This is a whole wavelength. And this one is 1/4 of that wavelength, as you can tell. Okay, this is the first harmonic. The second harmonic is going to look like this. Sorry, this is a third harmonic, but the second resonant frequency. We're looking at the places where the air columns will resonate. So the third harmonic will resonate. The second harmonic won't resonate. This is the second harmonic. And as you can see, it's an antinote at the end, at the opening of a column, which means it won't resonate. So then the third harmonic will resonate. And it will be given by this equation. Now the fourth harmonic won't resonate. The fourth harmonic is going to be like a third, except you're going to still have a note at the end, so it won't resonate. Now the fifth harmonic will resonate. It will look like this. Okay, given by this. So now we see that for open air columns, all harmonics will resonate. Well, a whole number integers will resonate. But for closed columns, only odd numbers will resonate. Only odd numbers will resonate. The first harmonic, the third harmonic, and the fifth harmonic. So if a question says, tell us a second resonant position, if they're referring to the second resonant position, and it's not talking about the second harmonic, because the second harmonic doesn't resonate. The circled areas here are the resonant positions, so if they talk about resonant position, you are not counting. It's going to be an odd harmonic in a closed column. So if they say, what's the frequency at the third resonant position? Where is the third resonant position? Well, it's 1, 2, this is the second resonant position, and this is the third resonant position. So don't get that confused.